option B, hence option B is correct. Zero diagram of impedance function of a network is given below. This particular diagram corresponds to which of the following functions? Here, from the pole zero diagram, this is the impedance function. So, S plus 3 S square plus 3S plus 2 is the impedance. So, Y of S, for simplicity, 1 by Z of S, I am constructing the Y of S. Okay. So, S square plus 3S plus 2 by S plus 3. So, here S plus 2 by S plus 3. So, if we compare this with a standard Y of S function, that is SC plus 2 1 by 2 plus 1.5, which is nothing but capacitance, and RL network is in series and in parallel with the capacitance. Capacitance value is 1 farad and inductance value is 1 by 2 henries, that is 0.5 henries, and the R resistance value is 1.5 ohms. Okay, this is the network. So if we look from here, we will get Y of S. Okay, for the given pole zero diagram, this is the network. Find the root locus for an open loop transfer function G of S and H of S equals to 1 by S power 4 minus 4. That is G of S, H of S, we can write S square minus 2, S square plus 2. So the pole locations are plus or minus 2 plus or minus J root 2. There are 4 poles. Okay. Here, see, there are 4 asymptotic angles. Those are, if we calculate the asymptotic angles, 2 cube plus 1 into pi, number of poles minus number of zeros equals to, these are the asymptotic angles. I am indicating with pi. We will get as a 45, 135, 225 and 315 degrees. So, asymptotic follows the poles are going to move from here k equals to 0 to k equals to infinite, means the poles are going to follow the asymptotic path in this way. Hence option B is correct. The open loop transfer function of unity feedback control system is given by G of S, the phase crossover frequency and the gain margin. The phase crossover frequency is the frequency where the phase of the angle of G of S is minus 180 degrees. That is, the angle of GS is becomes minus 180 degrees at phase crossover frequency. Minus 90 minus tan inverse of omega T1 minus tan inverse of omega T2. Okay, this is at phase crossover frequency omega P. Now this is minus 90 degrees minus tan inverse of omega pt1 plus tan inverse of omega pt2. So this is infinite. If we apply tan on both sides, apply tan on both sides. So this is omega pt1 as omega pt2 1 minus omega p square t1 t2. So omega p must be under root 1 by t1 t2. This is the phase crossover frequency. Here the gain margin is nothing but G of j omega at omega equals to omega p, we have to calculate the magnitude. This is if I am indicating with a, then gain margin is 1 by a. Okay, so if we substitute omega p in the magnitude, that is g of j omega is nothing but 1 by omega 1 plus s t1 t2 plus s square t1 t2. So if we substitute this one, we will get the magnitude as 1 by t1 and t1 plus t2 by t1 t2. Hence option A is correct. The frequency response of free emphasis and de-emphasis filters of an FM system are as follows. The PSD of the message signal M of t is given as SM of f. Okay. The scaling factor k is to be chosen so that the average power of the emphasized message is same as that of original message. Means after free emphasis, the power contained in the emphasized signal should be equal to the power of the message signal. The power of the message signal is nothing but integration of the PSD over the frequency range mentioned over there. So power of the message signal is I am indicating with PM, which is because here Sm of f is an even function, so I am taking integration from 0 to omega s naught here omega 1 plus f by f naught square df. So if we integrate that one, 2s naught f naught tan inverse of omega by f naught we will get. Okay, this is PM. Here the power of the emphasized signal is nothing but, suppose this is the pre-emphasis filter. Okay, pre-emphasis filter. This is the input PSD SM of f. Output PSD is nothing but filter, that is HPE of f whole square into SM of f. Okay, this is the output PSD. That is output PSD of free emphasis filter is k square 1 plus f by f naught whole square this one s naught 1 plus f by f naught whole square. So this gets cancelled. K square s naught is the frequency range over the range mod f to omega, mod f omega. So output power is nothing but 2 k square s naught omega, which is equals to 2 s naught f naught tan inverse of omega by f naught. S naught gets cancelled, 2 gets cancelled. Here k is chosen that f naught by omega tan inverse of omega by f naught 1 by 2. This is the value of k.